Hey everybody, welcome to chemistry class today. Obviously I'm not here, but I am here via technology. Yeah. Okay, so today we're covering metric conversions. So if you don't already have your notes out, take your notes out quickly and label them metric conversions. Now, I know, please don't be offended. I know that you've done metric conversions before in like middle school and stuff. But in chemistry, we're going to work with some different prefixes that you're not as familiar with. Before we do that, what's important about the metric system? What's important? Did you think to yourself? It's based on units of 10. That's the key. It's based on tens. Why we don't use it in the United States, I have no idea, because it would make life so much easier. Since it's based on tens, we have a list of prefixes. We have a list of prefixes that we use to show which unit of 10 we're discussing. And we're going to go in order from biggest prefix to smallest. These are the ones you must know. There are more. These are the ones I require. Mega, kilo, hecto, deca. Right here, this line represents our base unit, no prefix. And then we go to deci, centi, milli. See, those are the common ones, but now in science, we also need micro and nano. Now it goes on, but these are the ones that I require you to memorize. The abbreviation for all of these is pretty obvious. Sometimes deca, sometimes you'll get a capital D, sometimes you'll get a DA for the abbreviation of deca. And micro, since we've already used M on milli, is this Greek letter. That's the Greek letter mu. The Greek letter mu. All the rest of them, the abbreviation is pretty obvious. Now, what do they stand for? Mega stands for 10 to the 6th power. Kilo is 10 to the 3rd, 10 to the 2nd, 10 to the 1st. Base unit, if you have no prefix, that's 10 to the 0 power, which means don't do anything. Deci is 10 to the minus 1. Centi is 10 to the minus 2. Milli is 10 to the minus 3. Micro is 10 to the minus 6th. And nano is 10 to the minus 9th. So you have to, right now, beginning today, memorize these prefixes and what power of 10 they represent. Cool? Cool. This would be a good time to pause to let everyone catch up. Okay, so I really did pause and have a little sip of some drink to wet my palate. Now, here's the deal. I know that you learned to bump the decimal at some point in your life, and that works great, except when we get to our new prefixes, our micros, our nanos, our megas, then bumping the decimal doesn't work so well. So I've got a better system for you. I think you'll like this system. So here's how this system works. Let's just start with some examples. Let's start with, say we have 15 centimeters, and we want to know how many kilometers or kilometers that is. Now, the first thing you need to recognize is that the first letter is representing the prefix and the second letter is representing the unit. So I have a number of students who get used to thinking that everything metric has to be meters because the word meter and metric are, you know, they have the same Latin root or whatever. But that the unit that follows the prefix symbol could be any unit. That could be 15 centigrams to kilograms. 15 centibobs. Yeah, let's say that bob is a unit. 15 centibobs to kilobobs. But you get my drift. It doesn't matter. The prefix, since everything's based on units of 10, it's the prefix that really matters, not necessarily the base unit. Cool? Cool. Remember, the base unit is right here. Here's our base unit. What common base units do we work in? Well, for chemistry, the base units are pretty much gram, meter, liter, second, and if we're getting really crazy, mole. Okay? Those are pretty much the common base units. But remember, the base unit can be pretty much anything. It's the prefixes that matter. Now, how do we convert from 15 centimeters to some unknown amount of kilometers? Step one, we're going to use a system called dimensional analysis. Also known as the factor label method. There are tons of different ways to explain this. I mean, different names for this. Factor label method. No matter what it is, it's the best method. It's the most important thing you'll do in chemistry all year is understanding dimensional analysis. It will carry you through physics, through all kinds of cool other classes in college. So, here's the process. You don't get a choice. You have to do it my way. Clear? I know some of you are thinking, oh, I don't need him, but you have to do it this way. Write down what's given, 15 centimeters. Draw one bracket. This bracket is like a fraction. It's called a conversion factor. On the bottom of the bracket, the unit that's up here goes down here, centimeters. Why? Because when we multiply, that unit will cancel out because we don't want centimeters. We want to be in kilometers. And then kilometers, the unit you want to get, goes on top. So remember this helpful hint. The unit you want to cancel goes on bottom. The cancel unit goes on bottom. Whoops, sorry, I hit the right click button. And the unit that you want to get goes on top. I'm not writing that. You can write that if you want. All right, now what do we do? So now we have our units in the right place so that centimeters will cancel. Now we need to figure out the relationship between centimeters and kilometers. I almost said kilometer, which sounds like salami, which is good, as a matter of fact. So we need to figure out what goes where. If you would please, choose the larger of the two units. What's bigger, kilo or centi? Well, kilo is much, much higher, so kilo is the bigger unit. Put a 1 by the larger unit. So write yourself that note. I'm going to write it right here. Put a 1 by the larger, unit. Now, what do we do with the other unit? The other unit, you just have to put the difference in the powers. So as a power of 10, so this is going to be 10 to the something. Put the difference between the two prefixes. What is the difference between kilo and centi? Now this is like a number line, so be careful. So don't tell me 1, boys and girls. Do not tell me 1. Do not say 1. Do not think 1. What's the difference between 3 and -2? Did you say 5? If you did, that's correct. 3 minus -2 is 5. So I put a 5 exponent on that one. So again, a 1 goes by the larger unit. By the smaller unit, we have a power of 10, which represents the difference between the two prefixes, the difference in the powers. All right, now let's finish this. Let's finish this thing. Here we go, switching colors to dark green. So, how do we solve this? Well, we do 15 times 1. This is like a fraction. I like to just do 15 times 1 is 15, and then I divide it by 10 to the 5th. So remember this helpful hint. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. 15 times 1 is 15. 15 divided by 10 to the 5th. I can do that one in my head, but you may want to use a calculator. You're going to get, that is 1.5 times 10 to the -4th. Now we need to figure out what's going on with our units. So we had centimeters and centimeters. What happens in algebra when you end up with x over x? We cancel it out because that equals 1. And what's left? What's left is the unit we wanted to find, kilometer. Da, 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 da. That's the final answer. Now notice this number has 2 significant figures, and this number has 2 significant figures. So remember to follow your significant figures rules at all times from now on, forever and ever. All right, let's do some more examples. Okay, next example. Let's say we have 3.2 times 10 to the 8th micrograms. Let's do micrograms. So there's the micro symbol, and G means gram. And we want to know how many. Let's go to decograms. I'll use DAG is the most common way to do it, I think. So how do we do that? Well, step 1. Did you say write down what's given? So 3.2 times 10 to the 8th microgram, bracket, Microgram on bottom, decagram on top. Cool, cool. Which one's bigger, deca or micro? Deca is bigger. Very good. Very good. Now we need to figure out the difference between deca and micro. Here's deca. I think this is green now. Here's deca up here. Here's micro. So what is the difference from 10 to the first to 10 to the minus 6? So 1 minus -6. What's the difference? Think of a number line. Did you say 7? Don't just write a 7 though here in the bracket. Write 10 raised to the 7th power. Remember to multiply times the top, divide by the bottom. So 3.2 times 10 to the 8th times 1 is 3.2 times 10 to the 8th divided by 10 to the 7th. Gives me 3.2 times 10 to the 1st. Micro cancels out, and I end up with DAG, decagram. You could also write that one as 32 decagrams if you chose. You can write it in scientific notation or not. Cool, right? Yeah, not so tough. Not so tough. Not so tough. Not so tough at all. All right, one more example, maybe 2 more. We have 15 total minutes. I'm sure you're pausing it frequently to copy down problems and catch up and stuff and discuss anything. Mr. Moyer is here today to answer questions. I'm sure he can help you as well. All right, let's do 25 milliseconds to some unknown amount of microseconds. Should already be writing down what's given. Okay, so write down what's given. Sorry, I had to pause. You might have noticed I had like 4 interruptions. This class change is happening right now as I record this video. All right. Oh, geez, that's hard to tell the difference. This is a microsecond, and this is a millisecond. Crazy, 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 crazy. Which one's bigger? Did you say milli? I hope you said milli. Even though micro has a bigger exponent, it's a smaller number, a smaller fraction, or a smaller decimal, actually, okay? So milli is larger this time. Now we need to go up to our conversions and look at the difference between millisecond and microsecond. I'm circling it here on the screen. Can you see me circling it? What's the difference between -3 and -6? 3. Cool. So we put 10 to the 3rd right here. Now you'll notice this time the exponent and power of 10 end up on top. Why? Well, the 1 has to go by the larger unit, and so the exponent and power of 10 have to go by the other unit. So what is 25 times 10 to the 3rd? Well, that's 25,000, or 2.5 times 10 to the 4th. Cool. What unit is that? Milliseconds cancels out, and we end up with microseconds, which is what we wanted to end with to begin with. That was weird. Notice, please, boys and girls, that all we did that time is multiply by the top. We did 25 times 10 to the 3rd divided by 1. Do I really need to divide by 1? Isn't it going to be the same thing? It is. One more quick example. I have to be fast because I only have 15 minutes of recording time. Here's my last example. 100 centimeters equals meters. Now that one I would hope that you can do in your head. But if you can't, here's what we do. We say 100 cm. We draw a bracket. We put cm on bottom to cancel out, remember? And we put m on top because that's what we want to get. What's bigger, meter or centimeter? You need to recognize that meter does not have a prefix. Since it doesn't have a prefix, that means that is our base unit. So go up to your metric prefixes. Go up to your prefixes and look. Here's base unit right here in the middle. Right cheer. And we're converting to centimeters, which is right here. So what is the which one is bigger first? Well, base unit is obviously bigger, so put a 1 by that. What's the difference between meter and centimeter? We got 10 to the 0 to 10 to the 2nd is covered up from our previous problem. 10 to the 0 to 10 to the 2nd is a difference of 2. So put 10 to the 2 here. Multiply 100 times 1, which is 100. 100 divided by 10 to the 2nd. That should be pretty easy. That gives you 1. What happens to our units? Centimeters cancel.